Okay, I'm going to start this again. This is a little help for the hockey slap shot problem for the change in momentum and looking at the impulse. Okay, and I'm gonna make this a little bit more difficult because we're gonna say, well, what if it's a Major League Baseball player hitting the ball? All right, so we'll look at some of the things. So here's the basic idea. We've got it for your problem. The initial velocity of the ball or of the puck was 0 meters per second. So that makes it pretty easy. But let's take a look at a Major League Baseball being pitched in. Here it comes in. It's going this way. You can't see it. Notice it's going that way. And let's say right before Major League Baseball gets to the plate, it's got an initial velocity. In this case, now this is a velocity, and it's going in a negative direction. So therefore, we've got to say, oh, okay, so that's negative. Hold on, because it's 80 times about negative 35 meters per second. Okay, then it gets hit and is launched. I guess it kind of fades in and out when I put my hand here because it focuses on my hand or something. I don't know what the heck's going on there. Maybe if I pull this blind, that'll help a little bit. Yeah, that'll help. All right, so negative 35 meters per second, then bam, hits the bat. Boom, there's a big explosion. All right, that's that impulse. That's the collision. And then the baseball goes flying off this way. And we're going to keep it all in a straight line, and that makes the math a little easier too. At a final velocity of, let's say 40 meters per second, just to keep it nice and neat. And the mass of a baseball is 0.145 kilograms. All right? So what's the impulse for this collision? Well, the impulse is equal to the change in momentum. And notice I'm doing vectors here, so I've got the mass times v final minus v initial. Okay, minus the initial velocity here. All right. Now we're doing some pretty sophisticated stuff here. You know, we've turned up the volume on this a little bit. So the final velocity now, notice, is 40 meters per second. But what's the initial velocity? Negative 35. So we got minus negative 35 meters per second. Again, invoke the spirit of one of my favorite teaching icons of all time, Jaime Escalante. Negative times a negative is a positive, right? So, minus a minus. So we got the mass. Minus a minus turns out to plus 75 meters per second. Now, in yours, this one was 0. So it's pretty easy. You just take the mass times whatever the velocity was that you calculated from the miles per hour. I guess you all just did it. 0.145 times 75 meters per second gives us about 10.875 kilograms meters per second. Okay, there's no fancy word for momentum, for a momentum thing. All right, so that would be your impulse is equal to your change in momentum. That's how you would compute that. Now, for the baseball problem, I'm interested in what the force is that the thing was hit. Okay, so I've got this 10.875 now is equal to the average force times the change in time. So what's the average force that this thing hit? And the crack of the bat in Major League Baseball, delta T is equal to 0.011 seconds. Okay, so I'm going to take 10.875 divided by 0.0011 seconds, and I'm going to get a huge force here divided by 0.0. Oh, just 10, not 2. 0.011. Boom. 988 newtons. That's a lot of force. That is a lot of force. Okay, so there it is for a baseball, and the slap shot of the hockey and Serena's serve will probably be a little easier than that because the initial velocity was always 0.